pomeriggio, herzlich willkommen. It is 5 p.m. in Trieste and in Trento in Italy, but also in Mainz and in Halle in Germany. Thank you for joining us live today. Greetings to the audience which is joining us in presence in Trieste, Porto Vecchio, and also greetings to the audience joining us virtually from different time zones and many countries. Welcome to this special session featuring a keynote lecture by Professor Gerald Haug entitled The Climate Challenge Explained, or How to Navigate with Science for Climate Change and Other Crises such as COVID-19. My name is Lucien Brujan. I'm from the German Academy of Sciences, and I will be hosting today's session. Before we get started, I would like to introduce the keynote speaker and the moderator. The keynote speaker is Professor Gerald Haug. He is a paleoclimatologist, marine geologist, and paleoceanographer. And since March 2020, he is the president of the German National Academy of Sciences, Leopoldina, which is one of the oldest, or even the oldest, science academy in the world, created in 1652 with over 1,600 fellows from more than 33 countries. Gerald will say more in his lecture about what Leopoldina is doing day by day. Since 2015, Gerald Haug is also professor of climate geochemistry at the Swiss Institute of Federal Institute of Technology, ETH, in Zurich, and director of the Department of Climate Geochemistry at the Max Planck Institute for Chemistry in Mainz, in Germany. He studies Earth climate over thousands of millions of years. He analyzes sediment cores from the floor of seas and lakes and from other climate archives. These provide clues to the climatic conditions at the time of their deposition. And with this methodology, he can do quantitative reconstructions of past climate conditions and associated processes in the ocean, in the atmosphere, and in the climate system. And in addition, he also investigates the connections between climate variations and cultures. For instance, the historical periods of drought and the fall of the Mayan civilization, and the same with the weakened monsoons and the demise of several Chinese dynasties. His academic career brought him to different countries and different towns, from Karlsruhe, Kiel, Potsdam in Germany, Vancouver in Canada, Massachusetts and Los Angeles in the United States. And in 2007, he received the prestigious Gottfried Wilhelm Leibniz Prize of the German Research Association, BFG. He chairs the Science Advisory Board of the Alfred Wegener Institute in Kiel and the Science Advisory Board of the Potsdam Institute of Climate Impact Research, both very well-known institutions for climate research. I also welcome today's moderator of today's session, Giancarlo Sturrioni. Benvenuto. Giancarlo is an experienced science communicator and journalist. He studied biophysics, afterwards science communication, and did his PhD in risk communication. He works with Italian and international media outlets, L'Espresso, La Stampa, Focus, Rai, and so on, and is one of the co-founders of NatCom Communication Agency specialized on science communication. Giancarlo, you have the screen. Thanks.
Thank you, Lucian, and good afternoon, everybody. It's a pleasure to introduce and moderate this session, The Climate Challenge Explained, How to Navigate with Science Through Climate Change and Other Crises. Question mark, big question mark, yes, because we live in the middle of two global crises. One changed our way of life in a few months. The COVID pandemic is an epochal event. Yet has revealed the vulnerability of our societies, and once again the deep interconnection between humans and the environment. The second crisis occurred more slowly, but it could have even more destructive impacts. The climate crisis is already with us. Science is sound. Gerald Haug will show you that we cannot say we didn't know. But Gerald is not just a distinguished geoscientist. As president of the German National Academy of Science, Leopoldina, he also has a great experience as science advisor to the German federal government. at a time when science has returned to the center of the social and political arena. I agree with him when he says that idle is not an option. So what to do? Before giving him the floor, let me tell you that after the lecture, we'll have 15 minutes more or less for discussion, and Gerald will be pleased to answer your question. So ladies and gentlemen, Gerald Hall, thank you. And please, Gerald.
Yeah, thank you, Lucia and Giancarlo. It's a pleasure to be with you online, ladies and gentlemen in Trieste. It would be so much nicer to be with you in person and have that post-discussion over a lovely Italian dinner. What I'm going to do is a two-part presentation to somehow explain both crises, a slow and a very fast crisis with a deep connectiveness. So in the first part, I will have more my Max Planck scientist and ETH Zurich scientist hat on and try to give you from an Earth system science paleoclimate perspective a view on the dramaticness on reaching the 2-degree Paris agreement. And just like as in COVID, we are not doing very well in both crises. In the second part, I try to connect this somehow on what we can do to advise politics and citizens on both crises. And for those of you who have heard just a lovely lecture of Jeff Sachs, he said a lot about that. And the one thing is what we can do as scientists, but the other one is also directly connected to the listening capacity of our governments. So in the first part of my presentation, I try to bring what you see here, the Keeling curve, into a global, on a paleoclimate perspective. You do know that we have last year, the first time, passed the 400 parts per million CO2 concentration in the atmosphere. And we have to go back like 3 million years ago to have encountered in an ice-free northern hemisphere, in a much warmer world, a similar situation. And there are processes in the ocean-Earth system, which I think we understand quite well, to bring this into a perspective, but also to make the point on thresholds in the climate system. So if we pass too quickly the 2-degree Paris Agreement, there will be thresholds and feedbacks, which we call a runaway heating, which make this very dangerous. And it brings us to parallels to the COVID crisis. So what you see here is also the perspective that about half of the man-made CO2 is taken up, one half by the terrestrial biosphere and the other half by the ocean. So I try to explain quickly why the ocean at the moment is our best friend, even though the ocean warms, the ocean acidifies, and we have big feedbacks. And it all relates basically to the perspective where I believe from a paleoclimate view that at around 450 ppm, we add 3 ppm CO2 to the atmosphere. It's really, really hard to not consider that we have bypassed the so important Paris Climate Agreement, and we will go very quickly beyond it. So what you see here is that without those things, we already now would be something like at 430 to 450 ppm CO2, and the global temperature wouldn't be about 1 degree warmer, but it would be already 2.5 degrees Celsius warmer. So what you can see, and I'm one of those who strongly believes in the 2-degree Paris Agreement. Someone doesn't unfortunately work here. Right, is the effect on temperature. So the one half accumulating directly in the atmosphere is warming our planet. So at this point, this is somewhat an older IPCC figure, but I like it a lot from the Force Assessment Report, shows the warming we are in at about 1 degree Celsius now. And we have a cooling effect. The biggest cooling effect from dirt in the atmosphere are aerosols, dust, that's 0.4. So basically we are already now, if we consider a clean atmosphere, at somewhere close to 1.5 degree warming. If we burn all the fossil fuels we can access somewhat cheaply, the extrapolation till end of the century is that we go to somewhere with the new models we are facing now, a 5 degree warmer world. If we somehow do what the countries have promised for the Paris Agreement, we still would face something like a 3 to 3.5 degrees warming. So we are clearly not on track to meet the Paris Agreement. The big friend, our ocean, is shown here in a three-dimensional picture to show you what the ocean does for us. It's the upper ocean. You see here the Atlantic Ocean, the Indian Ocean, the Pacific, and the basic circulation patterns of the ocean. And it's the upper ocean, the upper 500 meters, which take up this man-made CO2, a little more than a quarter what we emit, mainly from fossil fuel burning. But what you also see, if you look in the middle of the picture, that's the Southern Ocean, or to the right, the North Pacific. The ocean connects very directly with the atmosphere. And the deep ocean, what you see here is dissolved inorganic carbon, has about 60 times more CO2 than the atmosphere. So it's the polar oceans which are this so important valve to exchange CO2 from the ocean to the atmosphere. The shallow ocean is taking it up, but there's, depending if we open or close that valve, the polar oceans, the Southern Ocean or the subarctic North Pacific, it's on how we exchange CO2. And we can with drill ships, infer from the past, if we drill in sediments, on how that works. And this is basically the process part to explain what I think is probably the single most important record in paleoclimate science, the CO2 record from the ice cores. So now we do a little time travel. And what you see here is the past 800,000 years, the CO2 concentrations. If we go up to about 280 to 300 ppm, that's a so-called interglacial or a warm stage, and the ice ages have 100 ppm less than an interglacial. If you've looked at the Keeling curve, I'm born in 1968, so I don't feel I'm a very old man. However, at the same 100 ppm, then it was here bringing the carbon cycle from an ice age to a warm stage is something what we've achieved in my lifetime, right? It's a bad achievement. So this gives you the dramatic scale. So in May 2019, we've passed 450 ppm, and if we continue as we do in a business as usual scenario, we can reach up to 800 ppm in the atmosphere. That was what the Earth's history has seen last about 50 million years ago. So it's a clearly dramatic impact of man on the carbon cycle. To explain this record, 100 ppm from an ice age to an interglacial and to the past time we had a 450 or a little higher CO2 atmosphere, the ocean played a key role. And the single most important aspect, now it's getting a little nerdy, that drives ocean circulation is the salinity of the ocean. The Earth rotates. The Atlantic is 1 per million more salty than the Pacific. This is why we have a Gulf Stream system and so on. But I want to pay your attention to the North Pacific. If you look at that number 33 there at Kamchatka, you see that blue aspect, and it's a light green with the lowest salt content of the ocean in the subarctic North Pacific, the Southern Ocean. And this is what we call a halocline. It's a density stratification which lids off the CO2 at the deep ocean. If you take this away, and there was the situation in a 2 to 3 degrees warmer world, you have a dramatic feedback, which could, if you would do this from a past perspective, add another 100 ppm to the atmosphere. We can measure those things if we do ocean drilling. So what you see here is a climate record of the past 5 million years. Left is today, 5 million years ago is to the right. And what you see here at about 2.7 million years ago is the biggest climate transition the Earth's history has encountered in the last 550 million years ago. That's the onset of Northern Hemisphere glaciation. In an ice age, New York was under ice and sea level was 120 meters lower. So these wiggles are very, very big climate changes. In an interglacial, there was at least ice as we see today on Greenland. And before 2.7 million years, there was probably a 400 to 450 ppm CO2 world, something we are basically entering or have entered now. And at 450 ppm, we can be clearly certain that we are reaching that Pliocene climate stage. That's in about 15 years if we continue as we do, and we are clearly not on track. So that transition 2.7 million years ago had a very simple physical reason where you connect ocean physics with the biology, the so-called biological pump of the ocean. And you see that climate threshold here. In another perspective, the middle picture you've seen, then there's the orbital forcing, the Milankovitch forcing, and the climate system is not that one-trick pony. The lower picture shows you the ice sheets and how they do with an albedo effect and this clear threshold value from an ice-free northern hemisphere to our modern climate system. So right then, we can measure, and this is now a core from the ocean drilling program, at 2.7 million years, something very simple. This is the algal production at this part of the ocean. And what you see in that Pliocene warm period, that 450 ppm CO2 world, the biological pump, the ocean production was something like a factor of 5 higher. And then it plummeted, and it plummeted in about 1 century. So it's a long time ago, but this went very, very quickly. So the question is what happened there and how reversible is this big step, which we see in the North Pacific, but we also see it in the Southern Ocean, which has even a bigger effect. So just a little introduction to oceanography. What you see at the lower left panel is the nutrient concentration, in this case, the nutrient nitrate from the South Pacific to the North Pacific. So the site you've just seen is where those isolines basically reach the surface, is sitting under a 150-meter thin density stratification called a halocline. In the Pliocene, that was removed, and you could expose those nutrients for 6 months, as long as you're in the Northern Hemisphere sunlight, to simply add a factor of 5 to 6 in nutrients, but also CO2, and the highest CO2 concentrations in the ocean are there. So if you remove that halocline and you do it in both hemispheres, you get, if you put this into some reasonably simple model calculations, 100 ppm CO2 change. And that's exactly the difference between an ice-free Northern Hemisphere and the situation we had over the past 2.7 million years ago, right? And that's basically the 2-degree climate target. If we overshoot too quickly, those simple physical structures connecting to the chemistry and the biology and the circulation to the ocean, they will disappear. And these are those thresholds which are very, very concerned about, which would further man-made warming. There are others like permafrost and methane and so on, right? But this is basically, for me, from a paleoclimate perspective, the 2 degrees Celsius target, that we can formulate a warm and a cold climate scenario. And in the warm climate scenarios, there would be this huge leak of CO2 from the deep ocean to the atmosphere. And that's what we can reach in a very, very, it will be not executed in the next decades, but if we overshoot too quickly, it's very, very hard to counter that. Okay, so I try to convince you from an Earth system science and Earth system history point of view that we are in a very urgent, very dramatic situation, and that the 2-degree targets also from the physical science point of view would be extremely important to meet. What do we need to do so? We need to basically go to 0 emissions at about the mid-century. And you've seen from the Keeling curve that we are basically not on track at all. And you know, when I'm giving those lectures and public talks since a long time, and I always said that 2020, it's the latest we need to have a turnaround globally. But I think mankind has never been further away from a turnaround. If we think of a perspective that, for example, we go the biggest coal revolution ever since the Industrial Revolution, that many parts of the world are still building up their energy resource by coal plants, not renewable at all. So I think we're in a dramatic situation. What do we do as an Academy of Science? We write I think, good statements on that. We have, for example, written right targeted for the European Green Deal and published it very recently, those statements with very, very clear recommendation. Yes, we need to go to carbon neutrality in 2050. We need to have clever technologies to do that, but it has a price. It needs to be funded. And this is why we are having a very clear opinion. I think amongst all scientists, I talk from natural sciences, engineering, but particularly also our colleagues from economy, that the only way we can achieve anything in the next decade or two, which is of the significant magnitude, is we add a carbon price. We need a CO2 price on a national, a European, but certainly on a global level. So it's clearly a global problem. It's a G20 problem, which are the main emitters. I'm clearly one of those, and we need some adaptation, but mitigation is still without any other alternative. And we are hoping that, for example, with those statements we wrote with all the academies in the country proposing some no regret measures, which is a CO2 price plus the obvious smart energy infrastructures. And it's very clear that we need in Europe to think this together. Germany alone will never meet this. So we really need the North and the South, and we also need to consider the role for North Africa, if you think of hydrogen, the sun, and so on, to meet any of those targets. This is all online, what the Leopoldina has done. It's all translated to English, and you may be interested. One pathway which is directly connected when it comes to sustainability and the environment is air quality. In Germany, we had a very heated debate on fine matter, on NOx and so on. So we wrote a statement on mobility and air quality with a special emphasis on nitrogen oxides. But it's also clear that air pollution is directly connected to the climate problem, but it may be bringing another angle. So if you think of governments, for example, in Asia, China, they know they have a huge problem with dust. And I once studied this over the entire Chinese history, climate, famines, dust, and that brings us also to the next one, air pollution and health has been ever since in those histories connected, and now we amplify the problem. I think it's known to many governments, so this may be another pathway by connecting climate and air pollution and health to get something done. Leopoldina has also brought this into together with other countries, the United States, Brazil, South Africa, to and the United Nations, to an action summit with the air pollution and health statements, and it's clear that the global emissions is a multifaceted problem, and we need to probably deal, this with those components in concert. That brings me to the current crisis and aspects Jeff Sachs has also just described in a lovely way. It feels to me as a geologist at the end who thinks of millions of years, of hundreds of thousands of years when I look at the Keeling curve, that was what we see here with the pandemic. It's like a dramatic fast movie, a time lapse. And we do have the opportunity, and Jeff also made the point, to do something about it. And some countries have shown that, yes, we can. Right? But others fare extremely poorly. And I think one of the conclusions we've learned is that those countries which have governments with a high rationale and a high listening capacity to us in the science community clearly fare much better than those populist governments where you see, and Jeff has mentioned it, including, unfortunately, the Trump administration at the moment, but many others who do very, very poorly at the COVID crisis, and they do, if you let them on a different time scale, also very poorly on the climate change crisis. So what have we done? On COVID, we wrote now 5 recommendations or statements, and we're doing the next, where we try to really bring the scientific rationale to politics. We've had recommendations on exit and recovery measures, on the principles of ecology. And it's been very important that all what we do getting out of the COVID crisis needs to have the Green Deal, the sustainable thinking in those huge investments, right? I mean, you know, all this debt has to be paid also by the next generation, just as the situation on a little bit of a different time scale on the climate change crisis. So I think it's very important to keep informing our politicians, our heads of government, that sustainability also out of the actual crisis needs to be the main driving thought of the post-COVID communication. There is an urgency. We do all face the problem of alternative facts, but I think the scientific community, with the exception of a few single voices, did very well. And in Germany, we have the pleasure that our head of government is Angela Merkel, is a physicist. She understands really our language. Language was a situation before, and the listening capacity here is extremely high. We also bring this together with many of you into the G20 and the G7 statements on the COVID crisis, but also bring aspects like the circular economy and the carbon price, also hopefully in this discussion. The next one is in Saudi Arabia, and I remain hopeful that we get something done and in there, but it's also clear that Europe needs to take a leading role. We have to interact with the Asian countries, and everyone is probably hoping that the US government is also getting somewhat more sensible in post-January. I would like to thank you for the attention. I would like to conclude that even as a paleoclimate scientist who thinks on a very long time scale, we need to act now, and we can act on both crises, but there's just no time to lose. We need to get over that winter with the COVID crisis, and some very simple measurements can do this. We hope all for a vaccine, but before that, it's really the simple things in life, like keeping distance, hygiene, and wearing a mask, which I hope brings us sanely into next year, that we can all meet again in person. Thank you.
Thank you very much, Gerald. Thank you. Thank you. Do we have any questions from the audience in Trieste? Is there any question? I have a lot of questions, but before I would like to give you the voice, the opportunity to ask Gerald Holger something more.
There is no question from the audience. Go ahead with your question for the time being.
Okay, my first question is this. Government promised a quick return to normality. But normality is at the origin of the ecological problems that cause climate change and make pandemics more frequent. So how to change all that, all this view? Because we need not just to solve what is broken. We have probably to change something more. What do you think about that, Gerald?
Yeah, Giancarlo, I mean, we need to fundamentally change several aspects. The first is our energy system. Everything we do and have done mainly is based on fossil fuels. And that's a gigantic system. But if we do this in an international collaboration where we use what we have available in technologies, but also as natural resources. Most important, the sun, and then transfer this to carbon neutral aspects and storage situations like hydrogen and so on. I think we can do that. This is a gigantic transformation. However, once those investments are done, and this is probably a 20-year effort, if you make a simple economic cost calculation, it's even worth it. So I think that 80% of, for example, the CO2 emissions can be done and reduced fairly easily if we go and act. The last 20%, they are much more difficult and get simply more expensive. So that's the most fundamental part is the energy system. And then we have to think about how we do this together and internationally, right? No country alone can stem that. And if we look at the world as we face it now, and the pandemic was an important lesson here, I mean, the world as a community, and we've heard from Jeff America First and whatever, was a lot of governments who are not in a very good shape and are not even willing to do that. It's going to be very hard to overcome a much greater crisis, a longer-term crisis, the climate crisis, than the pandemic. I think with the pandemic, I'm very hopeful that we get a vaccine and will be somehow done probably next summer. Right? It's a very good situation. But then, you know, it's the psychological threat of that crisis, and not to forget the other very important aspects, the SDG goals, the climate change crisis, to go out of that right now, beginning right now in the crisis with those major investments we're making. That seems to be key to me.
Thank you. Lucian, is there any question from the audience online?
No, for the time being, no. Okay, go ahead with your second.
Yes, we have some questions from the virtual community, and I will try to systemize them because some of them are shorter, some of them are longer. The first question, the second question is about, we don't have much time left. And this seems to be one of your messages because climate change is moving too fast than the society. So what do you think about geoengineering and trying somehow to find technologies, for example, to store carbon dioxide or methane, or manipulate clouds to produce rain? Is this the path to go to adapt to climate change, or should we not do it, and why? This would be the first one.
Right. I'm not a fan of geoengineering, and some of the technologies have little danger, are just very expensive. That's carbon capture and sequestration, right? I mean, the order of magnitude of those 10 gigatons of carbon or 40 gigatons of CO2 we are burning every year, it's going to be very hard and almost impossible to capture and sequestrate. Even though, why not? It's just expensive. We will never meet the mitigation side of reducing the fossil fuel burning. The fiddling with the atmosphere, with carbonates or sulfur or whatever, is very, very dangerous. Yes, you can, for at the end, a reasonably cheap price, a couple of billions, if you continue to do this, shadow the earth and artificially cool it. But that's basically the picture I like to use here, is you have a patient in hospital with cancer and you treat it with heroin, right? So there's a short relief, and that cancer patient, it can be still treated, healed, right? But that continuous injection of heroin. So what continues to happen if you do so? You still, of course, keep emitting and probably don't take care of it anymore, CO2. The ocean is taking it up, but it's acidifying the ocean. Right? There are dramatic changes and feedbacks which continue. And then there are calculations. If you think of my wonderful friend Tapio Schneider, the climate dynamicist at Caltech, right? What they found, there are other thresholds than I described, that if you have then eventually a double CO2 or triple CO2 atmosphere, all of a sudden you lose the tropical clouds, right? And this is where also sulfates and carbonates in the atmosphere are not helping. So if you lose those tropical clouds, who are obviously white, you have the chance to have a runaway heating globally of 4 to 5 degrees Celsius, right? So I think these are very dangerous experiments which we do globally with the Earth system, which I'm frankly very much opposed to, in particular, as we can still work on reduction and mitigation and treating that patient Earth properly.
Thank you. Another set of questions is on paying the price for climate change in terms of money. You mentioned about the CO2 price, and I have one question, for example. It's easy to say we need to pay for CO2. What about countries that produce energy from fossil fuels, or countries whose budget is dependent 80 to 90% from exports of fossil fuels? What do you say to that?
I see the problem. The main effect of a CO2 price, let's call it between $50 and $100 or euro, is that we need to reduce the coal, right? And that's, I mean, that's the key emitter. Many countries who have gas, which, you know, as a transition situation is clearly better than coal and oil, or oil who's anyway too precious to burn. You need oil for almost anything, for plastics and whatever we think about. I don't think there's that big enough effect on that. So we shouldn't burn oil. On the short term, gas is clearly more climate friendly, as we have not fully replaced the fossil fuels with energy. So the main impact of a CO2 price is to immediately reduce even the new building of coal plants. That's the crazy aspects. So of course there's a de-investment, but ultimately if you think of that carbon price and what it does, for example, for a liter of oil, it's not that much, but it would basically up immediately the efficiency and the worthiness to burn coal. And I think there's no alternative in a way of doing that. And there could be even considerations on compensations, and you also get that price in. But yes, otherwise there's no way to meet the Paris Agreement. We need to get immediately off the coal burning situation.
Yeah, thank you. Because you mentioned the governments in your part on scientific advice, there are several questions on that. Some are, I mean, obviously against people, politicians that are reluctant to talk to scientists. I won't give names here, but one question is interesting. You said that in Germany, the government listens to scientists, and this is not the case in every country. And sometimes they listen to the wrong people. But what about the citizens? Who listens to the citizens, and whom should the citizens listen to? And in brackets, disinformation, denial, fake news, and so on.
I mean, the decisions are made by our elected governments. So the citizens, of course, have the opportunity every 4 to 5 years to re-elect a government, at least if you live in a democracy, right? And of course, the word of the citizens is key. We as scientists can give advice on a rational scientific basis. You know, sometimes this is probably not so well liked, as there's a burden in this country. We have a big discussion, should you wear a mask everywhere or not, or whatever. But if we want to go somewhat sanely through that pandemic, it's the simple recommendations which have a scientific foundation, which are simply needed, and they need to be communicated, ultimately decided by politics. But I think we as a scientific community can also try to help to communicate on those needs with sound quantitative justifications on their role. There's a certain part of the population, and Jeff Sachs said it also before, who are probably just not very affine to science, and their education comes in. Education plays a very important role. So I think we should do anything in our schools and the school system to educate people that we come to somehow that common language and understand each other. That's clearly the way forward, connecting so the science, the education, to the citizens, to the political class.
May I? Okay.
Yeah,
If I may, can raise a question from Trieste.
Yes.
There was a question, but he has already answered properly, because one question was about the communication, how we can have the people more aware of the climate change. But I think that we have a very good answer about the schools, but if you wanted to add more, it's a welcome. I can add a second comment, second question that is more related to the, let me have a check. We are talking every time for the climate change, which is the worst scenario. Why don't we try to describe which could be a good scenario for us in next decade? So in order to have much more, to close for something positive and turn the communication in a positive way, like a goal to reach, something like that. Okay, thank you.
I mean, the Paris Agreement does that, right? And it shows somehow a pathway on doing that. I mean, what we learn from history, it's the rate of change. If it's too quick, it's very dangerous for societies. And COVID is an extreme example. But COVID is teaching us, and we heard it before, and I tried to explain it, that we can deal with this if we act quickly with simple measures at the end in a very effective way forward. And I think as we have almost 7.5 billion people on planet Earth, and we will be 9, the good news is that I think we can do this in a sustainable way. But whenever the rate of change is too quick and we fail to respond to this, we will face a very difficult situation. So the good news is, if we face those problems as mankind, yes, we can make those appropriate changes, but we need to act quick and in a very rational way.
Gerard, last year we saw the growing of a new generation of young activists, the Fridays for Future, for example, and I think that they change the discussion probably at an European level, at the government level. What do you think about that? What do you think about the role that can have a movement from the bottom?
I think I'm in great favor, and they're peaceful. They argue. They're non-aggressive, and they're very much like the Fridays for Future movement. I think it's important that it comes back to education, that it's exactly that young generation, school kids, students speak up, and even from my nerdy paleoclimate presentation, it's really the situation in the second half of the century, right? We are too old, but the main impact is happening then, and that's basically their futures and the future there. So it's clearly that we're having this big party based on fossil fuels, and it's not sustainable at all. So I find it very important that the young generation speaks up. They argue with us. They argue with the politicians. You know, their key point is listen to the scientists. Be rational about those decisions. And yes, we can. So that's in a way it's a very positive movement. And I think they're a little frustrated with the COVID crisis is just overprinting the entire communication. And I'm very hopeful that next spring, when we hopefully have overcome COVID, that they come back very, very strong and speak up, and we hear their voices when it comes to global sustainability and the climate change crisis.
Lucian, last one, very quickly.
Yes, very quick one, because I find it interesting. I will just read it. Thank you very much for sharing these insights. You are a real researcher doing real research. So, what is your personal belief? Do you think we will have an ice age, a desert age, or a new world in 100 years from now?
No, in 100 years, no matter what we do, we will not have an ice age. If there wouldn't be that man imprint, we would have the next ice age in something like 80,000 years, right? But I think what happens is that we bring the Earth and climate system to a completely new stage, and if we continue to do so, what we do, we're not going back 20,000 years ago to the last ice age, we go back 50 million years to the Eocene warm period, and we do this for a long time. So what I'm personally hoping is that we can mitigate it. One important aspect was in there, the desert. The 2-degree target has probably even more with the temperature to do with rainfall. Right? If you think of the monsoonal world, that time 3 million years ago was something like colleagues have described as a permanent El Nino with the rain belt further south in the Indian Ocean. So one effect for 3 billion people living in Asia would be a reduced monsoonal rainfall, and it would be a complete catastrophe. So a golden rule is wetter gets wetter and drier gets drier, and there will be big shifts in the rain system, which I haven't talked about, which would be beyond the sea level at the very quick rate, then bring a complete new situation to ENSO circulations, the monsoonal world. And the key aspect we need, of course, for anything to keep us alive, that's rainfall. So these are going to be very big swings, bigger than now, and this could be a very difficult situation, particularly when it comes to rainfall.
I'm very sorry I have to interrupt the discussion, but we have run out of time. I'm grateful to all you for your attention, your question, and the discussion. I'm grateful to Gerhard Hall for his excellent, very, very interesting keynote lecture. Thanks also to Lucian, and obviously thanks for all the staff of ESOF. Good evening, everybody, and enjoy ESOF. Thank you very much.
Thank you.
Thank you.
Bye.